Okay, my name is Ivan, and here is my report about visualization of oxygen distribution section caused by color and object. The introduction. The coral and algae is both an important ecosystem engineer. The most important thing is they produce oxygen, and the oxygen will be used by the reef community and cause the oxygen consumption. And many studies have investigated the variation in oxygen concentration. But in this scale, we can't use normal way to test it by point because oxygen will vary spatial and temporal resolution across the gradient. And this is why we choose the planar oxygen octopus. And this is the green algae we choose. It's called species. And the coral we choose is Fabia coral. This both is the common coral in the ocean. And it's the introduction to what we want to know. We want to know the oxygen distribution produced by the coral and algae between day and night, and also know the oxygen distribution produced by the coral and algae. In fact, by hydrodynamic, it means water flow, and also the interaction between coral and algae. Okay, here's some number. Let's talk about the oxygen planar octopus. This is a new technology to observe the oxygen concentration. So we need a observer sheet and a LED light. Its lambda peak is at 445 nanometer. And when the light shoots on the observer sheet will excite it and fluoresces. And when it fluoresces, it will grow at red. The red lambda peak is around 550 nanometers, and we can capture the light with the camera. And this situation is at a non-oxygen situation. But if there is oxygen in this situation, the oxygen will absorb the light, the blue light, and cause the fluorescence will be diminished. And we take photo, then put the photo into the program to analyze the photo, and we can visualize the oxygen. Okay, here is the experiment setup. We need a box, and you can make from glass or something. And after the sheet is the most important thing. And at the start point and the end point, we need a oxygen probe. Both we need, and we need to use this to calibrate the system. And we need a light to simulate the sun, and a camera to take a photo. And a blue LED is to excite the observer sheet, and a contact sensor to measure the light, and the temperature sensor to measure the temperature. And for each experimental need to run 3 times, and the test organized were placed in the design notch of the flow chamber. And just the previous one, that's box. And an observer sheet was placed in the vertical plane. You need to cover the test object, the corals and algae. Also, samples were exposed to 4 different treatments, which is at the daylight and the dark condition and the non-moving water and the flow rate of 5 centimeters water. And also the temperature need to control at 26 degrees, and the test object need to eliminate in the tank for 48 hours. And this is the photo test photo we take. You can see the water flow is from the left to the right, and the oxygen concentration, this bar is the oxygen concentration. You can see the color and between the picture and this bar. And the result as static water. The oxygen background value is at daytime is around 161, and the nighttime is 164. And also, the daytime, the algae will produce oxygen more than the coral, and at the nighttime, it both reduce the oxygen production. And we can see at this picture, we can see the oxygen flow at a vertical way. It's just flow out. It is because the oxygen is too much for the water, and it just flow outward. And you can see both at coral and algae. Also this one is coral and this one is algae. And at the daytime, the oxygen may not available to the community, the bio community, but it rather shorten vertically through the water column because it is too much oxygen. And at nighttime, there were no noticeable difference of low oxygen zone between the coral and algae. And this is the result with hydrodynamic. The water is flow from the left to the right, and this icon this is at the daytime. And we can see the oxygen produced is pushed by the water to the left, to the right. And when it's at nighttime, you can see the oxygen reduced as the previous steady water. And the oxygen concentration may differ by more than 60% along distance of less than 10 millimeters. It means here to here, it can differ by more than 60%. And the study suggests that oxygen can be produced by the benthic organisms are affected by light condition and the boundary layer thickness and the function of flow and surface type. It means any shape of the coral or algae will change the water flow and the oxygen flow. The image generated in our study suggests the simple point measurement is not accurate because the water and oxygen will flow, and you can't measure it at the single point. It will change with space and time. And also, this is the result of algae-coral interaction. We can see there's the interaction between algae and coral. There's a low oxygen zone, and at daytime and nighttime you can also observe it. And the oxygen concentration is around 97, and at nighttime it's around 80.74. This hypothesis zone at interaction interface have been suggested to be drive coral algal composition process. and have been noted by other studies, but could never be shown in their full extent and under very light condition and hydrodynamics. So this is why you're using oxygen, plain oxygen observers. Okay, this is a great discussion. Through this result, we can find out this new technology provide a new opportunity to clearly visualize and quantify this pattern. Further, our results suggest that the pattern of algae induce hypoxia in competitive interactions between corals and algae may be a common phenomenon. Okay. Yeah.
All right. Alisha.
Could you turn to the result?
Which one?
The picture. This.
This one.
Could you explain why why will the vegan become the high oxygen concentration?
Repeat her question.
Why there's hypoxia zone like here?
No, I mean the green one.
The green one. He's
No, on the coral. Right.
oh here.
Yeah.
This is because this is the coral, and this is at daytime. It produces a lot of oxygen that's this zone, you know, and it direct shoot on the up to the sheet, and then it flow outward. Okay.
Arlin.
Could you please go back to method?
Method.
What exactly is apoptosis sheet?
Repeat.
Yeah, what is upload the sheet? This is a technology invented in 2011 or 2012. It's kind of a new technology, and it is it's a sheet. When something shoot on it, it will glow, and if the oxygen contact to the sheet, it will absorb the energy. It will absorb the energy, and the light will diminish.
Rebecca.
Yeah.
How do you choose green and
I think why we choose these two kind of algae and coral. I think it's because it's very common or something. Yes, I think it's very common.
Repeat.
In your results of program, coral results.
No, we float one water flow
with
also.
hypoxia zone. Can you explain why does the hypoxia zone exist?
Why does the hypoxia zone exist? It may be because these two species is competitive. Is fight each other or something. It will generate a hypoxia zone and non-oxygen zone.
Jack.
Page 9.
Okay, page 9.
Can you explain that what are A and B difference?
A is for algae, and B is coral. And this is both at daytime. sorry I didn't explain in my speech. Yes. This is Arlin and power.
Ethan.
Continue to the hypoxia equation.
Yeah.
You can see below the hypoxia zone, we also have some upstream.
Did you say here?
Yeah. Below. It's the upper
Oh,
zone.
the upper one here.
Yeah. No, I say the B picture and the hypoxia zone, the upper.
Here.
Yeah. Also have the upstream. So how do you?
It is because it still have background upstream concentration,
Okay.
and it's actually consume the oxygen.
So this hypoxia zone is the coral and alga that eats the.
This I don't know, but it's mentioned in other report or other paper.
I think he has chosen a paper which is the result of which are mainly visual, so that is actually easy to present. So it's very straightforward. So considering the presentation of the slides, you can see that that will be really wordy, a lot of text. So I have a feeling that it's text from the paper, maybe. Yeah.
It's a little.
Yeah, and also somewhere here. Yeah, so it's I have the feeling that you can do better. Based on your QA and the way that you present, you could have done better. You do not need this lengthy text, and we do not have to read this lengthy text. You can give us some short sentence keywords, and you can read the full sentence. Okay, I hope that you can do that next time. And I think the method is nicely presented, although I have a feeling that on top of this complex background, I hope that the color, the contrast, like the uptones or something can be stronger. It's too many things on the slide. Yeah, the background is too colorful.
Okay.
And let me check something. All right. Yeah, it's really nice that you have tried to animate the analytical procedure here. It's really nice. However, I still hope that at the end you can show the. I remember this original design figure. Yeah. Usually, I would say if there's no such figure in your paper, then you are free to do animations. But if there is such a figure, like this one, please show it. You can show it, and then you can say, okay, you explain the detail using the animation here. But it's always good to show the figure in the original paper. All right, again another wordy text. Okay, and then comes to here. So next time, please, going to your results. So next time, please tell us what's this, yeah, and also you might this is not asked by the audience. Maybe you might give us a brief discussion. Apparently, these are the same figure, same results, but why are they two different color scale? You might consider explain it briefly, or you just show one if you do not want to explain.
Okay.
Otherwise, I know what's going on, but somebody might be thinking, what's the difference? Especially the color scale is different. So please either explain or take one of them away. And from time to time, there is font things. That's distracting. Okay, and And here, I think your sequence of presentation is you show the result first, and then you talk about its meaning with very long text. If next time, it would be great if you can show the result and use the space to show your main discussion. The way you can do it is actually here. It's very easy. You don't need to. You can just make it 2 slides and use the space here for your discussion, point 1, and then the same slide again for your discussion, point 2. That would look like a little bit like animation, but it would be always good to link your discussion to your data instead of show data first and then discussion separately. It will be better to do that. It's always good to look at the data and discussion together. And next time, I hope that, because as several of the audience asked, you might consider discuss more about the Haas here. Yeah. Instead of just saying, okay, here is Haas. Right. And I don't think there is any discussion about Haas. Yeah. It's just a competition. Why? I don't know how much is discussed. All right. And you have a discussion slide, but it's again wordy. I don't remember what's inside. But I remember you have a nice. You did not say it's a perfect slide, but it's actually a perfect slide. Here you said you want to know this, and that, this brief, and it would be good if you can recycle the slides here. Usually, I think I say that once. You convert it to conclusion, and here you keep the sentence, and here you say our finding is our finding. Right? So that will give your slide a sense of coherence. 一致性. You throw out 3 questions, and you got 3 answers. All right. It's a nice talk. So thank